Yes, students, now I have defined you the properties of divided difference. First property you know, second property you know, and now we have defined you the third property. The nth divided difference can be expressed as the quotient of two determinants each of order n plus 1. Yes. The proof of this property we have defined here. The third difference is, we're taking here from third, the third divided difference is f of x0, x1, x2, x3. This is equal to, which is equal to sigma, yes, f of x0 and divided by x0 minus x1, x0 minus x2 and x0 minus x3. This can be again solved by, this is again can be written as sigma, yes, f of x0 and the difference product of x1, x2, x3, yes, and divided by difference product, yes, difference product of x0, x1, x2 and x3. Yes, clear it? Okay. Now, by the Vanderbilt, Vandermonde's determinant, we know that difference product of x1, x2, x3, this is equal to x1 square, x2 square, x3 square, x1, x2, x3 and 1, 1, 1. This is defined like that. Okay. So from here, f of x0, x1, x2 and x3, yes, this is sigma of, yes, numerator and denominator, and numerator can be written as f of x0 here is, and the difference product of x0, x1, x2 and x3, this can be written as x1 square, x2 square, x3 square, x1, x2, x3, 1, 1, 1. Okay. This, and now divided by, yes, divided by this one. So divided by, this can, everything is divided by, this can be written as, divide again, determinant of x0, x1, x2, x3, yes, so this can be written as, yes, so this can be written as x0 cube, x1 cube, x2 cube, x3 cube, yes, x0 square, x1 square, x2 square, x3 square. Now x0, x1, x2, x3, 1, 1, 1, 1. Clear? Or this can be written as or f of x0, x1, x2 and x3. This can be written as dividing this and this, or you can say that this can be f of x0, f of x1, f of x2, f of x3. This and divided by no determinant. x0 square, x1 square, x2 square, x3 square, x0, x1, x2, x3, 1, 1, 1, 1. If you are operating f of x0. Is clear? If you are operating this one, then you get this one. And divided by the same, or you can say that, or you sign the symbol, this one. That is divided by x0 cube, x1 cube, x2 cube, x3 cube, and x0 square, x1 square, x2 square, x3 square, x0, x1, x2, x3, 1, 1, 1, 1, like that. Proceeding in the similar way, we can represent a higher order differences as the quotient of two determinants, each of order 1 more than or order of difference. Similarly, you can prove that the nth divided difference can be expressed as the quotient of the two determinant, each of order n plus 1. Clear? This is the property, third property of the divided difference. Now I defined you, the next fourth property. In the fourth property, in next video I will define you the fourth property. So, okay, thank you.